Hello, and in this video we're going to briefly talk about how to compute correlation coefficients by hand. So, if we look at our example here, we've got two variables that we want to assess the correlation between someone's borderline personality disorder symptoms and their theory of mind score. There's some research suggesting that theory of mind difficulties may lead to some symptoms of borderline personality disorder. So this is just some fictitious data looking at that relationship and BPD symptoms. There's 9 possible symptoms. So there's we've recorded a person's borderline personality disorder symptoms, and we've also given them a theory of mind test and recorded their score on that. We could obviously see what the correlation is between these variables in SPSS, but the whole point of this video is we're going to show you how to do it by hand if you don't have access to SPSS or a computer when you're doing correlations. So, the first thing you need to do is compute the arithmetic mean, or just the regular old mean of both these variables. So that's the sum of all scores divided by the number of scores. So for our BPD symptoms, the mean is 4.4, and for theory of mind, the mean is 65.6. We also need to compute the standard deviation, which in itself is quite laborious, but I have a previous video on, so I'm not going to go into that. Once we have that data, we can actually start working out our correlation. The first thing you need to do is work out how much each score deviates from its mean, and this is similar to what we did in the video for working out the variance and the standard deviation, but because we have two different variables, we need to do it separately for variables. So first of all, we're going to take BPD symptoms, and we've got our mean for it there. We're going to take the first score and subtract the mean from it, which in this case is 4.6, and then we're going to do that for all the scores. So you see there we have all our raw deviations for the x variable. Now we're going to do the same for the y variable. So our first score is 33 and our mean is 65.5. So take 33 from 65.5 and you get 32.5. Minus 32.5. So there we get our deviations, and if we put them together in a table, this is what you get. Now, in previous videos, what we did, such as for the variance and standard deviation video, was we squared the deviations to get a sum of squares. But in this, we can't do that because a negative correlation is meaningful in itself. So we don't want to get rid of the negative numbers. So to calculate the covariance, all we need to do is take those two deviations from but the two variables and multiply them together. So the product of deviations for the first person is they got their deviation for the x was 4.6, and that deviation from y was minus 32.6. So we multiply them together and get minus 149.6. If we do that for all our scores, we see those are the deviations we get. Now to work out the covariance, first thing you need to do is add up those the products of those deviations. So we add all those up and you finally get a score for these data of minus 206.76. Now to calculate the covariance, what we do is take that sum of squared deviations and divide it by the number of the of participants we have. So we had 5 participants in this case, so we divide it by 1 less than those 5 participants. So it's basically like calculate any mean. You take the total score and and divide it by the number of people. So our covariance is minus 51.69. Now, that we're using that as a stepping stone to calculate the correlation coefficient, because a lot of people are more familiar with that, but the covariance is meaningful in itself. A covariance of minus 51.69 means that as one variable increases, the other decreases. That's what the minus is about. So that tells us that there is a negative relationship. But to get a standardized measure, we need to calculate the correlation coefficient. And how do we do that? Well, we use the standard deviation. So that covariance expresses the relationship in the units that the variables are already measured, but a correlation expresses the standard deviations. So what we do, we see on the next slide, we take the standard deviations for both variables, which were, if you go back to the first slide, were calculated in the first slide, and we just multiply them together. So 3.21 times 23.46 equals 75.31, and if we take that and now we substitute it into our correlation equation, we see what we do is we take the covariance we calculated and divide it by the product of the standard deviations, and we get this gives us a value that, like, correlation can only be expressed between minus 1 and plus 1, so we get a correlation coefficient of 0.69, so quite a strong relationship, really. Anyway, this was an example of how to calculate Pearson's correlation coefficient for the relationship between two variables. One thing we haven't done is a significance test or calculated a p-value for the significance of the correlation. That's going to be coming in future statistics by hand videos. So thank you for watching this video, and I hope you've enjoyed it. Bye bye.